Well, there you are. But John and I already had the suspicion that it was being recorded from the very beginning by diverse security agencies across the world.
Probably.
Yeah, exactly. Okay, so without much further ado, I'm really, really happy, and a great thank you to a very old friend of mine, Dr. John Crowley. John and I first bumped into each other, and we were colleagues for a while, working as both as professional social scientists at the time. John was at Sciences Po, if I remember rightly, and I was at a small institute called the ICCR, the Interdisciplinary Center for Comparative Research in the Social Sciences, which always was a challenge to say once you had a couple of wine. John and I worked on a number of projects together, a number of EU projects together, and then we both were actually part of the ICCR as it expanded to Paris, which is where John is based, from Vienna to Paris. And then both of us went our own ways, and John went to join the UNESCO as the chief of section for social transformation, which you were at for a very, very long time, what, at least 15 years? 18 years. 18 years. So you were at UNESCO for 18 years, and I met you a couple of times there. We actually went to Slovenia together. You invited me to Slovenia, and in 2021, you decided you'd had enough of the UN bureaucracy, as it were, and you decided to take it to go self-employed. Since 2021, you are the CEO and chairman, not as it said in the erroneously said the careman, although you are very caring, as we already established. You're the chairman of a company, a consultancy that works in sustainable energy called PHGD. Without further ado, the floor is yours, John.
Thanks very much, Stephen. Indeed, pleasure to not resume, because we didn't just resume, but to continue that long track record of collaboration. So yeah, what I'd like to do here is talk about a specific project, which is part of my current portfolio, the Flexeole project, which is about small-scale wind, and also offer some reflections about what it's like to run a project like that. So I'll try to characterize the project in more general terms than the specifics, and use that as a peg to hang some reflections about technology, capital, human organization, and the current state of the startup world. So PHDD is a company. It's also a group of companies with various business partners. I started some separate legal entities in which PHDD has shareholdings. Flexeole is both a project for me and an independent company, but that's not hugely important for these purposes. What I'd like to focus on is the content of the project. Flexeole is the meeting of a use concept and a technology concept, and they combine to produce an idea for reinventing small-scale wind. Now, what you see on the slide is an artist's impression. We haven't literally built any capacity in Mongolia yet, but it will be a very cool place to do so. And it's an artist's impression that is a reasonably realistic representation of what a Flexeole unit would look like. And so you can see small scale, designed for energy autonomy. Next slide, please.
Yeah, hang on. Go on. That's the next slide. Yeah.
So what we're responding to in general terms is unsurprising. We need renewable energy. Why? Because there are very good reasons to want to get out of fossil fuels, not just to do with greenhouse gas emissions, but also issues of energy security, particularly viewed from Europe, and issues of non-greenhouse pollution connected with fossil fuel use and the whole fossil fuel chain. As the old quip goes, but it remains very true, many wars have been fought about oil, very few wars have been fought about sunshine. Alongside that, as the International Energy Agency has emphasized, energy efficiency is probably the most important short-term challenge to respond to the transformation of the global energy system. Energy efficiency can offer significant potential to make the difference in that key bridging period between now and about 2030, 2035, before major infrastructural change can come online, before, for instance, any new generation of nuclear power could come online, even if there is public and political support for it, and the time when significant progress needs to be made on reducing the energy content of GDP, and in particular, greenhouse gas emissions. But again, they're just one part of a bigger picture. Yet, and this is worrying, energy efficiency improvements appear to be slowing. There are a number of reasons for this. One is that despite recent spikes, energy remains relatively cheap, and simply increasing the price is politically unacceptable. Therefore, there's no price pressure for efficiency. Secondly, a lot of efficiency issues are locked into the infrastructure cycle and change only slowly, except in times of major disruption or except where there are major policy levers. And third, the so-called Jevons effect operates powerfully. Jevons, late 19th century English economist, William Jevons, who came up with a well-known theorem that most efficiency gains are dissipated into higher consumption. So making sure that efficiency doesn't drive more consumption, but derives less consumption for the same aggregate benefit is a challenge. New solutions are needed. And I'm not proposing here a solution to the whole picture, but something that is both a direct solution for one small part of the big picture and exemplary of the kind of approach that I think can help to address the bigger picture. Next slide, please.
Yep. Sorry, bear with me. That's it. That one. Sorry.
So no need to, now there's some very weird things in this slide and I'll fix them at some point. Why some letters are lowercase and some uppercase, I have no idea. So my apologies for that. I'm usually extremely pedantic about such things and I don't know where that screw up came. I'll blame it on conversion to PDF to get myself off the hook. So the Flexeole project, and you can guess if you know anything about Greek mythology, you know where Flexeole is coming from. Aeol was the Greek god of wind. So we're talking about flexible wind. Renewable energy plus energy efficiency plus electricity cost control. That's what we're talking about in a specific niche, and I'll say more about that niche in a moment, which is the 50 to 150 kilowatt range. Next slide, please.
Yep.
So these, that's another artist's impression of a different place in France this time. A Flexeole turbine is about 25 meters high, depending on capacity. So that's what we mean by small. We're not talking about here about looking for solutions at the domestic level. There are technical reasons to think that household scale wind isn't very relevant anyway. I won't go into the technical reasons, we can discuss separately. Even though you can easily buy a 3 kilowatt unit in a hardware store, it's not going to do much for you except decorate your roof and make you feel good about your green credentials. It's not going to produce a lot of electricity, and the ROI, if you calculated it, would very probably be negative. However, 25 meters is big enough to be meaningful in technical terms and small enough to respond to a couple of important challenges. So obviously, like any wind application, wind is a renewable resource. The energy is zero emissions, even though, of course, the turbine life cycle isn't. Common objection, which, of course, can be answered with figures. Importantly, the landscape impact is limited, both by the height and by the length of the blades. At a time where, certainly in France, also in the UK, two countries I know best, but in quite a few other places as well, there are increasing objections, to large-scale land-based wind. Typical land-based turbine these days is 4 megawatts, 180 meters high, with blades that are about 110 meters long, and people don't want them anymore. In addition, the objections aren't just aesthetic. There are objections, possibly in bad faith, on health grounds, and objections in good faith about the impact of large wind farms on grid stability. Often in France these days, optimal siting for wind turbines based on the wind resource is unachievable because the grid upgrade requirements to site the wind, the turbines, would be too onerous. And I was discussing this with some of my people that I know in Germany recently, and of course Germany has particularly strong north-south grid constraints that actually get in the way of using wind potential, including offshore wind potential, effectively. And the cost of grid upgrades is enormous compared to the cost of the wind turbines themselves. So that's a real bottleneck. Finding ways around that bottleneck is a way of improving the overall efficiency of the grid and making it possible to site wind where currently it wouldn't be possible to site it. Thanks to the technological approach, which I'll say a bit about in a moment, this kind of turbine gives high availability, flexible energy, contrary to what's often assumed with wind. Wind is dispatchable. Indeed, wind turbines are often turned off for dispatch when they're overproducing, and reducing grid supply needs by the ability to put production close to the consumer, instead of putting production in the most convenient site and then building or expanding the grid to match. And finally, the energy is competitive, even at this scale. Of course, you're losing out on economies of scale, but you compensate for that by higher efficiency. Next, please. I won't go into the team. You can see me on the left with nicely combed hair and a tie. And Jean-Luc Tivol, my co-founder, invented the technology. Interestingly, because he's a helicopter enthusiast. And he actually used ideas. He's part of a non-profit association that maintains old helicopters. So he knows a lot about rotatory technologies, as the slide says, and used some of his ideas to rethink what a wind turbine blade should look like. And that's actually what we've patented. And Stéphane Toussaint is a very experienced engineer working for a big construction firm who brings us a lot of very hands-on experience about how to. Now, there are some very embarrassing typos, but I won't draw your attention to them. I need to fix all of this. Brings a lot of experience of a big industrial corporation to bear on designing this particular project. Next, please. Interestingly, someone picked us up as having international potential. We were called a top energy startup to watch in 2023 by a Turkish consultancy, which is very nice. They looked at 3,310 startups and picked us up as one of 10, which is unfortunately not bringing any money or markets, but is nice because it means that the idea has been recognized by the kinds of people who do these kinds of rankings. Next, please. The PhD, as I said, is a group. So we're working on a wind energy project in the context of a bigger picture. And the bigger picture is given by our corporate slogan, which is on the logo, but probably a bit too small to read: producing better, consuming less. And in our view, a lot of what we do in this area is consultancy, but we're also keen to develop concrete technical solutions to respond to this challenge. How can we produce better? In other words, not just use wind or the sun for that matter, but do it in better ways, ways that are more resource efficient, ways that leverage the potential for systemic change. And how can we use those levers to consume less, not simply switch fuels from fossil fuels to alternatives? I won't go into all the macro arguments, but suffice it to say that my own view, which is shared by many people in this space, is that if we simply replace fossil fuels by renewables, we will crash the system. The challenge is both to replace fossil fuels by renewables and at the same time to re-engineer the system so that it becomes much more efficient at meeting human needs with less waste, less loss, and less structural inefficiency. As you probably know, 50% of electricity produced in a typical grid is never consumed. It goes into the grid's own electricity needs, heat-related losses, transformation losses, and a range of other things, including, of course, theft, which in some countries is a non-trivial part of what gets produced and never built. But even in Western European countries, a lot of the electricity just gets lost in the system. It's produced and no one ever pays for it. That's inefficient. If we can re-engineer the system to make it much more efficient, then we can, at the same time, do the switch to non-fossil energy and reduce the overall burden on society and on the environment of producing the electricity that's needed. Note that the point here is not to say people need to consume less in the sense sacrifice their consumption, their well-being, their prosperity to save the planet. Some people say that. It's not really my style. It's not the kind of language I want to use. Maybe at some point we will come to that crunch, but I think we can avoid it. My point is we can get the same benefits from far less resource use if we didn't have systems that would completely engineer the structural waste. Next, please.
Yeah.
So to summarize, 3 big challenges for wind, and Flexeole is a solution. Intermittency is inherent in wind energy. The wind doesn't always blow at the same speed. This is statistically predictable. It's not a form of unreliability, as often argued by fossil fuel advocates, but it's definitely a form of intermittency. Intermittency can be reduced by flexible technology that operates on a wide range of wind speeds and reaches nameplate capacity at lower wind speeds than other forms of wind energy. Second challenge, project complexity and length and siting limitations. In France, these have become dramatic. It basically takes 10 years to build a wind farm. And if you think cost of capital and the implications of all the uncertainties built into legal procedures to authorize wind siting, then you're actually damaging the economics very seriously. We can do it in 18 months. We know because we have done it. We've got the permits for our prototype site. And because we're below various administrative thresholds, we can go much faster. And speed is money in this business. And third, grid dependency. When you're feeding the grid with intermittent energy that is complex to site, you're actually adding to grid complexity and producing system level costs on top of the costs for your units. If you can connect direct to the consumer, possibly even on a microgrid or off-grid setup, but that's not necessary, you're producing optimal economics. For wind, as for solar, the economic optimum is on-site consumption, not building massive amounts of capacity to feed the grid and then dealing with the problems at the grid level. But this needs a different approach, which is very easy for solar because solar is inherently modular, a bit trickier for wind because people have stopped making small wind turbines because of the fashion that big is beautiful, in this area at least. We have solutions for that. Next, please. The technology itself has 2 key features. The first is the blade design. As you saw from the mock-ups, from the artist's impressions, there are 5 blades, not 3, and they're much shorter than wind turbines traditionally are. In fact, they look a bit like the very old wind turbines that you see on films set in rural areas of the US in the 1950s, when every farmer had a small wind turbine, usually for groundwater pumping. These were very cheap, very inefficient. What we're doing is taking that intuition close to the consumer, local needs, keep it small, but trying to build maximum efficiency into it. And the efficiency comes from two things: the blade design, for which we now have a patent. It's not just making them shorter, it's also the geometry. You can look up the patent, it's public, of course, like all patents are, and see exactly how the geometry improves efficiency by reducing what's called the vortex effect, which is end of blade turbulence, basically. And secondly, this is designed for dynamic real-time control, changing the orientation of the blades to address instantaneous wind conditions, thereby capturing the wind even when it's not blowing from the dominant direction. Usually wind farms, partly because of their sheer size, are built in terms of a dominant wind direction, east-west, north-south, or whatever. And if the wind is coming from a different direction, which it inevitably sometimes is, then there's a huge loss of efficiency. And indeed, you might see the wind turbines curtailed, not because there's no wind, but because it's not blowing in the right direction. These units are small enough to be continuously adjusted to wind direction as well as wind speed, thereby capturing maximum efficiency. Which means that we can reach, at least on models, a 40% effective load factor. So production divided by capacity times 8,680 hours per year, compared to 30% for most models on the market, including the big ones. So you're losing something in terms of economies of scale by sheer size, but compensating for that by a 10-point improvement, a 25% improvement in effective load factor. Next, please.
Yep. Oh, sorry.
What we're doing at the moment, and this is where I move into some general considerations about what it is to run an industrial scale tech project these days, is trying to build our prototype. Because of course, no prototype, no validation of model production, and no certification for sale. We have a very detailed certification protocol, everyone does in the industry, which we've done with DNV. I'm sure you all know DNV, one of the big certifiers in the business. And there's all sorts of things you have to do to certify a wind turbine design. And to do that, you need to build a full-scale model and run it for 6 months. We have the site for that. This is a mock-up on the actual site where the prototype will be located. We have the permits. We don't have the cash. And raising cash is hard for early stage industrial scale tech projects. Some of you may be well aware of this. In addition to the prototype site, which is the one on the right at Cheminat in Ardèche, which is a department southwest of Lyon in the center of France, we also have other expressions of interest from potential customers who want to site this kind of capacity on land that they control. For instance, in the city, small town of Eure in the Drôme department, which is just across the Rhône from Ardèche. Eure is the departmental sub-prefecture, as the French call it, so the kind of county town. And they are very interested in using some spare land they have to supply the tertiary office complex. 150 kilowatt scale is ideal for that kind of application. There's no way they're going to put a 4 megawatt turbine. It would be technically impossible in regulatory terms, and wildly overpowered compared to their needs. 150 kilowatts, now you're talking. And the same is true for many categories of potential consumer. Next, please. So the identified markets, and identified is obviously a key part of trying to raise the money, showing that if the prototype can be funded, then consumers will follow. Based on what we've done in France, but not only in France at this stage, is first farms. Farmers are very concerned about energy costs. They have available land, and they're usually already quite heavily invested in various kinds of energy solutions, including solar. Basically, every farmer in France has solar on the farm building roof. these days, and a lot of them are into biogas as well. Wind would be added value because at latitudes like those of France or Germany, wind and solar tend to be very complementary. They're both intermittent, but they're intermittent in different ways. Seasonally, highly complementary, and even at a more detailed hour-to-hour level, often with useful complementarity. So that wind plus solar gives much less intermittency than either alone. Secondly, biogas facilities. Biogas needs energy to keep the digestate warm and to keep it moving. You have to rotate the facilities to stop everything jamming up. And traditionally, biogas uses part of its own gas to feed its energy needs. At a time when gas is very valuable, particularly biogas, for regulatory reasons, that's a significant economic loss. If you can replace the gas consumption for on-site needs by on-site electricity production, it's a win-win for the biogas operator. And we've also checked that industrial SMEs, generic industrial SMEs, not industrial SMEs with heat applications for which this kind of power isn't relevant, they too are very interested in doing this. They've often invested in solar already. They realize the limitations of solar in terms of intermittency and available space, and are looking at options to supplement existing solar with on-site wind. But it has to be small enough to go on-site, which is the market that we're responding to. That's where the use concept, as the slide says, meets the technology concept. Next, please. The development options, hybrid wind and solar, I've already mentioned. And we are a solar operator too, so we can think about that package. And I think it's one of the most interesting and very practical horizons. There's no technological difficulty there. It's just about creating the right kind of sales pipeline, and therefore the right kind of language to convince people. Building a circular wind economy is something that's been brought to us as a challenge. There's a huge number of small-scale units that are being scrapped these days, many incidentally in Germany. They're being scrapped for up-powering because siting is difficult, so the best option is to use an existing site with permits and grid connections. And you can up-power by getting rid of old 100, 200, 300 kilowatt turbines and replacing them by 750 kilowatt models. That makes sense for the operator. It's creating a massive glut of equipment that you can buy online for very low prices. It shouldn't be scrapped because the steel masts are reusable way beyond the retirement of the small units. They're reusable way beyond the natural life cycle of the blades or the generators. And you would want a circular wind economy, but that requires some serious process re-engineering. We're looking at how to do this for Africa. That's exciting, challenging. It's mainly about logistics, and it's going to be fun to try to do it. And storage solutions, adding storage to the wind and solar, is an exciting horizon for off-grid autonomy. Not everyone wants it, not everyone needs it. It's not economic for everyone. And there are people who want it who realize once they do the sums that it's really far too expensive for them. But still, off-grid autonomy or quasi-off-grid, in other words, you have a grid connection which you only use very rarely, is going to become an important part of the energy landscape for the future as storage develops. And of course, storage is being transformed by electric vehicles. Every electric vehicle is a mobile storage unit. As the tipping point of electrification of transport becomes reached, storage is not going to be a constraint anymore. It's going to become an opportunity. And re-engineering production around storage, rather than doing it the other way around, is going to become an important horizon. This is something we have started working on conceptually and want to work on operationally. Next, please. And I need to speed up. Some figures, so you can compare to other kinds of wind or other kinds of electricity production options. we're talking 4,500 euros per installed kilowatt. That's competitive with solar. Obviously, there are cheaper options. It's cheaper to do big wind on a per kilowatt installed basis, but big wind has problems that small wind doesn't. And we're talking about levelized cost of production over the lifetime of the equipment of about 12 to 16 euro cents per kilowatt hour, which is significantly more expensive, of course, than some other options, including big wind, which can be as low as 4 to 6. But there are compensating advantages. One of our challenges is to push the advantages so that these figures don't look like a barrier. Frankly, no one has made a fuss about the figures so far. People understand that this isn't directly comparable with other kinds of wind options, but should be seen as a specific niche. Next, please. Yeah, this example is actually quite interesting. We put it partly because we're very invested in the Auvergne-Rhône-Alpes region of southern France. The Drôme and Ardèche departments are at the bottom of that map on either side of the Rhône. But more importantly, because this is pretty typical of France and of many European countries. There's a lot of wind potential, particularly along the river valleys. And basically, nearly everywhere, including everywhere in red, is a no-go area for wind. If wind is to be installed in this region, which is a pretty big region, highly industrialized with Lyon as its capital, then it's going to have to be a different approach to wind. And what's true here is true in many, many parts of Europe onshore. No arguments against offshore wind. That's a completely different market. This is about how to make good use of existing wind potential onshore. Next, please. Our timeline, and we haven't been able to go as fast as we would have wanted, which comes to the general question of what running this kind of project involves. And I'll summarize it by one anecdote, which is actually multiple anecdotes turned into one. It's you go to see people to try to get funding, whether equity or other. You explain the project to them, and they say, yeah, your project is great. Come back next year when you've made some progress. And of course, if everyone says that to you, then you will never make any progress. That is the difficulty. And one of the difficulties, of course, is that basic industrial applications don't have the wow factor that, for instance, app-based projects do, or that radically new breakthrough technology does. So you're not getting people's pulse rating just on the fact that this is incredibly exciting. ROIs for anything to do with manufacturing are low compared to other sectors of the economy, and particularly the digital economy, simply because there's a lot of capex required up front that necessarily downgrades ROIs. So you're struggling against those two things. Fashion and hype is driving capital towards the digital economy at a time when we desperately need capital in the industrial economy. That's what we're struggling with. And I think it's a very common struggle throughout Europe. The US seems to have done better by throwing massive amounts of money at the issue, often in very indiscriminate ways, the so-called IRA, which for people of my generation with an Irish background is a very confusing acronym, the Inflation Reduction Act. But what can you do? It's what they call it. You'd think President Biden, with his Irish connections, would have thought of this and might have kept away from that acronym, but maybe it was some kind of joke. Anyway, and of course, countries in Asia, including China in particular, have been much more effective in keeping the balance here between the financialized, digitized economy and the economy of things you can drop on your foot, literally or metaphorically, the manufacturing economy. I think this is perhaps the most important general lesson from the Flexeole project. Next, please, and perhaps we're getting to the end here. Yeah, I won't go into financials because this isn't an investment pitch. So of course we can talk about that if you're interested. But just a very quick look at those financials shows that the payback time, as you'd expect with an industrial project, is longer than investors would like. They would like to see much faster paybacks, in which case it's not going to be in the hard industrial economy. It's going to be elsewhere. And that's a big challenge. So maybe I should stop there. I've given you a flavor of the project, some general considerations about the challenges, and very happy to hear your feedback, questions, objections, offers of large amounts of equity at very high valuations, gratefully received, of course.
Okay, thank you very much. Thanks a lot, John. That very good, very interesting. I did have a question from the chat. Bear with me for a moment. I'm trying to figure it out. Our colleague Manfred, who's listening to this while having his, he's at the physio, poor guy. He said, you mentioned CapEx. Is there no possibility to run an OpEx model, no business model in the market? Leasing models, renting models, usage-based consumption?
For the consumer, yes, of course. And very possibly rental approaches are going to be optimal for the consumer and therefore optimal in commercial terms. But to manufacture, you're still going to need CapEx. And it's either your own CapEx, if you build your own industrial facility to manufacture stuff, or CapEx embedded in your partner's investments, which they're going to charge to you to manufacture under license or to outsource various kinds of manufacturing. And even if you're buying, for instance, secondhand masts, which is something we've been looking into, you can buy a 30-meter steel mast from a decommissioned German turbine for as little as a few €1,000. And probably if you negotiate well, they would pay you to take it off their hands, if you're clever. There's that much going to scrap. And it makes sense to avoid scrapping them literally. But that's still going to be CapEx in the sense that you're investing in creating hard industrial capacity that will be depreciated over time and needs to be funded upfront.
Yeah. Manfred sort of is saying, well, what about B2B? So sort of doing the things you'd say to what you've just argued in the B2C as a B2B service,
but all of this is B2B. These aren't household scale units. 150 kilowatts is, I mean, it's the equivalent of what about 12 to 15 households in terms of typical sign-up capacity. So we're talking about something of much bigger scale. So it's an inherently B2B market. The consumer is a business level consumer, like a farm, small industrial business, or maybe a consumption collective at village level or something. That would also work, but that's still a B2B, not a B2C market.
Manfred is saying
how do you structure it for the buyer of the turbine or the kilowatt hours? And you can have a kilowatt hour model. In fact, there are 3 models. You can sell the units, you can sell the capacity, or you can sell the kilowatt hours, the actual energy produced. And each of those is a different kind of business model in terms of how a consumer of your product, it's a different product, how a consumer of your product gets access to the product. Either a wind turbine, guaranteed available capacity, or kilowatt hours with certain kinds of guarantees. And each of those have different economics. But at some point, it's high capex to produce the damn things and install them.
Yeah.
And installation is non-trivial. About half the cost of a Flexeole unit is going to be civil engineering, which is typical for this kind of project. Putting them on site, wherever the site is, costs about as much as making them in the first place, which is what you would expect.
Yeah. Excellent. Thanks, John. I've got loads of questions. Also, I must admit that's a talk I have never heard from you before, and it's quite odd to hear you do that sort of thing. And I will drag you back into something that I feel more comfortable with in just a second. But if there's no questions from the floor at the moment, Manfred has sort of said that they're running a similar model for their heat waste. I believe that's what you're talking about, Manfred. Supply. Perhaps I'll put you two in touch when he's hardware models. They've got something similar for our hardware models, hardware supplier. I'll put you in touch. Perhaps you two can.
Yeah, with pleasure.
Yeah.
Maybe there's, and I'm very open to the idea that there might be something really clever that they're not thinking of.
Yeah.
And that's the whole point of interacting in this kind of format.
Yeah. Timo?
For me, it was very interesting to hear that apps are more interesting or more exciting kinds of innovation or products. I mean, Stephen,
doesn't feel like it, no.
If you come from this field, I guess it's always that if you do apps all the time, then it gets less exciting, and you get excited by somebody talking about steel and heavy machines and doing something like that. So, and I see also on the market that energy and energy produced by consumers, like solar energy and these small panels, became already mass-market product, bought by consumers, installed by consumers, and I wonder if it's really the problem of the product, or if it's not advertised in a more emotional way. What do you think? Is it the point in that you might set a better stage and better scene and advertise it in a more emotional way?
Yeah, I completely agree. That's hugely important. But for that, of course, we need a commercial unit available for sale, which means we need certification and we need manufacturing capability. But down the line, how you sell is really important. Now, we have experience of this because I'm involved in B2C solar as well, plug and play solar, which is one way of using solar power in a very decentralized way. As you know, when you do rooftop solar, about half the cost is just putting guys on the roof. And of course, the guys need to go on the roof and they should be paid for going on the roof. But it's half the cost of your project per kilowatt. If you put it on the ground, which is not always possible, but often possible at small scale, then you can basically divide the cost by 2, which is very attractive. And we've done this in France. And what has always struck us is that, and if you look at advertising in the French market, this is basically how it goes. Yes, there are some people who feel an emotional commitment to saving the planet or whatever. But for most people, it's economics only. That's the only thing that counts. And all the advertising is about how cheap it is and how much money you're going to save. And I think, generally speaking, it's like with bikes, it's like with organic food, many other aspects of the green transformation. You've got 15 to 25% of people possibly who are motivated ideologically to do certain things. To get outside that minority, which admittedly might not matter commercially if you have a good niche, but these are very competitive niches. To get outside that minority, you have to shift the argument to this makes sense for you economically. It's not a sacrifice, it's not an ideological commitment, it's good business. Now, we'll see. We haven't designed advertising yet for a product that isn't on the market yet, though we hope it will be by next year. But it's an interesting question whether this should be marketed as smart technology that is economically valuable to consumers, or another way of committing to a green, social, environmental, and even geopolitical transformation. I don't know. Probably we'll test both.
Yes, I mean, it depends on the market you are and the target audience. I had the feeling that it's from a technological point of view, very exciting product. Maybe for nerds, I don't know. Maybe it's just me speaking there, but I could imagine a very really exciting spot around this product.
Absolutely.
I wonder.
Yeah, I hope so. Maybe I should just clarify one thing. When I was talking about exciting, I was talking about in the eyes of people with capital to allocate.
Yeah.
And what excites them is the prospect of exponential growth. And as it happens, I don't know if you know Salim Ismail, the author of Exponential Organizations and the founder of the Exponential Organizations Network. I know Salim a bit, and I was even on his podcast a few months ago. We had a discussion about these and other things.
Yeah.
And clearly, what excites the people with capital to allocate is the prospect of exponentiality. The idea that some things, once they take off, grow so fast that they make fortunes. You're not going to do that with an industrial product. No. Because the cost structure is just different. You can build a very sustainable, profitable, long-term business, but it's not going to grow exponentially. And that's the difference. Now, the dream of exponentiality might be a fantasy. In fact, it is a fantasy, because anything exponential eventually breaks down. Nothing can be exponential forever. But no one's alive forever, and no one's in the business forever. So if you have exponential growth for 4 or 5 years and then exit, you're going to make a fortune. That's never going to happen on a high capex industrial project. Never.
Yeah,
I see.
Now, you could say, what about Tesla? Which is a good question, very interesting question. And one possible argument is that Tesla was exponential so long as it wasn't really manufacturing, because it was selling a dream, and a dream that was largely defined by software, not hardware. Once Tesla becomes a car manufacturer, the model will shift. Gigafactories are hugely expensive. And Musk has said this himself. The hardest thing is manufacturing, which means that you shift from the exponential path to a much more linear path, which can still be profitable and attractive for investors, but will never give that sheer adrenaline of exponentiality. That's what I was trying to capture when I was talking about exciting.
Thank you.
John, just a thought. I mean, we're running out of time here. Thanks again, but just a thought. So one of the many projects, so we're in very much, as Timo's just pointed out, we're an IT firm. We do very large scale IT services, and we're in that digital space that you seem to think looks all so exciting, and we see that somewhat differently. But one thing that we are doing with the X Creation thing is that we're looking at projects like your own. In particular, I'm looking at one on charging stations, and it's about the siting of charging stations, which are far lower capex, whether you have an AC charging station or whether you have a turbine. I should dare say, is a big difference. But what we're trying to do is we're trying to use data and the digital economy. So I was going to ask you about this. I don't think you have the time, but I mean, if you look at your roadmap and you look at that, I mean, you've already alluded to it, that there seem to be a lot of administrative hurdles and barriers that make the process that is painful as it is, because it has such a big capex. You know, there's such a big, you've got to pay so much, and it just creates tiny little frictional inefficiencies along the way, which make the thing so painful that you don't really want to, that people don't really want to consider it. And that's sort of something that we do quite a bit with. So there's the digital economy and the digital solutions here that can perhaps grease those squeaky bits in that industrial process.
I agree, and I'd actually go further than that. I think that's true, but probably marginal compared to the real holy grail, which is monetizing non-investment, non-consumption, non-production. There are examples of this that exist already. You can be paid not to do stuff, often in very inefficient administrative rather than market-led ways, like farming set aside, where the European Union pays you not to produce food. And this is basically a corrupt system, which indeed organized crime has made a lot of money from. But there are many other areas where non-investment in particular isn't monetized. And the best example of that is the grid. By installing on-site electricity production, you're avoiding the need for very expensive investment in grid upgrades. And that value, which is a very real social value, just evaporates. The grid company doesn't really capture it because that non-investment is just, it doesn't turn up anywhere in its books. It just doesn't happen. and you're not recompensed for that non-investment, even though you were the generative cause of the fact that the investment wasn't required. When I referred earlier to a new value chain, this is what it's about, and that relies essentially on information flows and digital technologies. And indeed, we have a project, but it's very much a drawing board project. It didn't get off the ground. Working in particular with an operator in Switzerland called Nomica, which I have a very small stake in, and which is having trouble getting off the ground, even though they designed a very nice concept, which is finding ways of tokenizing non-investment, non-consumption, non-production through smart contracts that can allow the people whose actions create the conditions for avoided investment, consumption, production to be recompensed for that. Not through the typical traditional kind of administrative process based on tax credits and set aside and all that other stuff,
and stuff like that,
which is ultimately a bureaucratic nightmare, but through a straightforward market mechanism. But that requires very good identification of the generative factor, which is the investment in on-site capacity, the production of kilowatt hours, whatever. Very good identification of the information ecosystem. In other words, knowing how grid investment has been avoided by the fact of on-site investment in production, and then matching those various contributions to a social benefit through a rich finance information ecosystem. This is what Nomica wants to do, except that it's actually hard to get it off the ground. And it doesn't have to be done through any particular operator. Lots of people are trying to do this, but there's something missing. And I think what's missing, interestingly, is the social science, which brings us back to our core business. In other words, what connects those things is a social web of connections. It's about behaviors, values, meanings, and institutions. And if you try to do it in purely tech terms, you'll probably miss the point. Because this only works if by creating the finance information ecosystem, you're creating new incentives for behavior and levers for institutional change.
Yeah.
And if you don't do that with the social science lens, you're going to fall flat on your face.
Absolutely. Well, it looks like we have to have you back, and we'll have to have you back with Nomica as well. Thank you very much, John.
Thank you.
That was super exciting, super interesting. Yes, I think we'll reach out to you. We really need to talk some more, because particularly on that interface of what you're just talking about, I think we would have some interest there. Thank you very much. Have a nice weekend. Say hello.
Thanks.
Say hello to Vanessa, and thank you once again. Take care, everyone.
Thanks again for the invitation. Thanks, everyone.
Thank you.
Bye-bye.
Bye.
Bye.